This is our spectrophotometer lab. I'm Gia.
I'm Sahasra.
I'm Julia.
First, fill your separate cuvettes with your solutions and fill another cuvette with your blank. Make sure not to fill a cuvette past the line. Open your app and make sure you're scanning from wavelength 800 to 200. Make sure to take your gloves off before touching the mouse.
Quantitative data focuses on how much light is being absorbed to determine concentration, while qualitative data focuses on which wavelengths are absorbed to understand the identity or characteristics of a substance. The reasons why you would scan across all wavelengths is to detect unexpected peaks that indicate contamination or errors, or to find the best wavelength range for examining chemical reactions or changes over time. The highest point on this curve represents the lambda max, which is the wavelength at which the substance absorbs the most light. Determining lambda max is important because measuring absorbance at this wavelength provides the most accurate results.
Use your blank to zero the spectrophotometer by first cleaning the correct side of the cuvette, the one with the arrows pointing down. Then open the lid and place the cuvette inside with the sides with the arrows facing where the light will be sent through. After closing the lid, click the 0 button, then create your new file, name it, and click OK to record the absorbance for your blank. Repeat the process of cleaning each cuvette and scanning across the wavelengths for each, remembering to close the lid each time. Once you've scanned all your solutions, click Finish to see your final graph.
The Beer-Lambert law relates a solution's absorbance to the concentration of the absorbing substance, stating that absorbance is directly proportional to both concentration and light path length. Beer-Lambert's law is associated with the equation A is equal to epsilon LC, where A is the absorbance, which represents the amount of light the sample absorbs. E is the molar absorptivity of how strongly a substance absorbs light at a specific wavelength. Then L is the path length in cm, and C is the concentration in molarity, or moles per meter. According to the relationship between absorbance and concentration in the Beer-Lambert law, absorbance increases linearly with concentration when epsilon and B are constant. While performing the spectrophotometer analysis, zeroing the spectrophotometer is necessary. Otherwise, not zeroing the machine with the blank means that the spectrophotometer doesn't subtract the absorbance of the solvent, cuvette, or instrument background. This would further result in the measured absorbance will be higher than the true absorbance of the sample, and this could lead to incorrect concentration values since extra absorbance is added to the solute. In result, it messes up the accuracy of the Beer-Lambert relationship.
Don't forget to properly dispose of your waste and clean up your space.
To the hard place.